Question 30c. In 2010, the city of Pythagoras modelled the predicted population of the city using the equation P equals A outside of 1.04 to the power of n. That year, the city introduced a policy to slow its population growth. The new predicted population was modelled using the equation P equals A outside of B to the power of n. In both equations, P is the predicted population and n is the number of years after 2010. The graph shows the two predicted populations. Part 1. Use the graph to find the predicted population of Pythagoras in 2030 if the population policy had not been introduced. Let's refer back to the graph. We'll locate 2030 on the x-axis. From that point, project upwards until we strike the dotted line, because the dotted line represents the population growth of Pythagoras if the policy had not been introduced. So where it strikes the dotted line, project across to the y-axis, and then using the grid, read off the population, which is 6,600,000. In part 2, in each of the two equations given, the value of A is 3 million. What does A represent? Let's locate 3 million on the y-axis and notice that it corresponds to the year 2010. So A represents the initial population of Pythagoras. Part 3. The guess and check method is to be used to find the value of B in P equals A outside of B to the power of n. 1. Explain with or without calculations why 1.05 is not a suitable first estimate for B. Now, part of my solution here, I've written that B needs to be less than 1.04, since any value of B greater than 1.04 implies a faster population growth. Referring back to the graph, this is the value B equals 1.04, and that results in this dotted curve. If the value of B is greater than 1.04, rather than getting this solid curve here under the dotted curve, we'll end up with a solid curve above the dotted curve, which indicates a faster population growth. So we need a value of B that's less than 1.04. Part 3, 2. With n equals 20 and P equals 4,460,000, use the guess and check method and the equation P equals A multiplied by B to the power of n to estimate the value of B to 2 decimal places. Show at least 2 estimate values for B, including calculations and conclusions. Now the value of A is 3 million, and we're going to use that and the value of n, and we're going to guess some values of B to try and get a number for P very close to 4.46 million. Now the value of B needs to be less than 1.04, and that's been established earlier. So let's guess B equals 1.03. Let's check that. 3 million multiplied by 1.03 to the power of 20 gives around 5.4 million, which is definitely too high. Let's guess B equals 1.02. Let's check that. 3 million multiplied by 1.02 to the power of 20 gives 4.457 million. So pretty close to 4.46 million. I think that's very close, but let's check another value of B. So let's check 1.01, and that would just add a little bit more weight to the argument that 1.02 is our best guess. So guessing B equals 1.01 and checking that, 3 million multiplied by 1.01 to the power of 20 is around 3.66 million, which is definitely too low. So the value of B would be 1.02, correct to 2 decimal places. Part 4. The city of Pythagoras was aiming to have a population under 7 million in 2050. Does the model indicate that the city will achieve this aim? Justify your answer with suitable calculations. Now we're going to let n equal 40. Now where does that come from? If we go to the graph, when n equals 20, that corresponds to the year 2030. When n equals 30, that corresponds to the year 2040. So therefore, when n equals 40, that corresponds to the year 2050. So letting n equal 40, we have the value of A, which is 3 million, and we found our value of B, which is 1.02. Value of n is 40, of course. Substituting all that into this formula here, we end up with 6,624,119. That's correct to the nearest whole number, which is definitely less than 7 million. So therefore, the city will achieve its aim based on this model.